Today we're going to talk about 10.8, the power theorems. This will be another quick lesson, just talking about 3 quick theorems and then a couple examples. The first theorem is called the chord theorem. And what you'll have is you'll have 2 chords as shown in the diagram. And what that theorem says, the product of the segments of the chord will equal the product of the other chords. And how that happens is, let's say that we draw more chords between AB and DC, creating 2 triangles. Now, since we have vertical angles here and here, and you'll also notice that arc C is the same as arc A, and since they're the same, that means that these angles have to be congruent. Therefore, the 2 triangles, triangle ABE, will be similar to triangle CDE. And since that happens, that means that the sides are proportioned. So AE over EB would be equal to EC over ED. Therefore, the product AE times ED equals BE times EC. And again, that comes from this segment times this segment will equal this segment times that segment. The second theorem is the tangent-secant theorem. Again, if I draw 2 lines creating 2 triangles and 1 larger triangle, you'll notice that if I look at the larger triangle and this smaller triangle, they both share angle O, so they have angle O congruent. And if you look at angle NPO, and if you look at angle M, hopefully you'll notice that those are congruent. Again, because they share the same arc. And inscribed in chord tangent angles are half what the arc are. And if they share the same, then therefore they would be congruent. So, again, let's mark that. Angle M and angle NPO congruent. That means that triangle OPN is similar to triangle OMN. Therefore, the proportions would be equal, and PO squared equals NO times MO. And if you look at that as a diagram and you're trying to figure out what that actually is, you take the tangent line and square it, and that equals the product of ON times MO. And finally, the last theorem, secant-secant theorem. Based on very similar examples from the last 2 theorems, the triangles would be congruent or similar, therefore the proportions. Therefore, what this theorem says is ST times SR is equal to SW times SS. All right, and we'll take a look at 3 quick examples. The first one that we see is a chord example, and what that theorem said is that if I take the product of this times that, it should equal the product of the other 2 segments of the chord. So we set it off as 3 times x equals 5 times 9, and you solve for x, which would be 15. The next example is secant. And remember what secant says. It says you take the segment of the secant from the outside to the outer edge of the circle, but then the full length of the secant, that equals the other segment from the outside of the circle to the full secant. So this one would be set up a little bit differently. We do 3, which is this right here, but then we multiply it times this, which is 3 plus x, that's the full segment. And that equals 5 times 15, because that's the full segment. You'll solve, so you'll get 45, 3 times 3 plus x, divide by 3, 3 plus x equals 15, x equals 12. Actually, let's back up slightly. This should be 75. Divided by 3 is 25, therefore this should be 22. And finally, tangent-secant theorem. The tangent-secant theorem states that you're going to take the tangent line and you'll square it, and that will equal this part of the secant line, which is 4, multiplied by the full length, which would be 16. So you get x squared equals 64. Take the square root, which would be plus or minus 8, but we just want the positive, therefore x would be 8.